Okay, good afternoon, everyone. So, welcome back to session 4. That we should start with the first paper, first topic, RPKI ASPA Crossing the Routing Security Gap. Please welcome Chiang Hermoso from APNIC to the stage.
Hello, and good afternoon, everyone. We are in the last session, so please bear with me. There's also no more coffee outside, so we'll have to deal with keeping you up for the rest of the day. Anyway, my name is Shane Hermoso. I'm the development manager at APNIC, and thank you to ThaiNOG for the opportunity to speak to you about RPKI ASPA and how it closes the gap in routing security. So for the longest time, we have been talking about routing security in RPKI. I hope that you're all now familiar about RPKI. RPKI is the routing security framework that enables resource holders to verify that their resources against internet resources. Using this framework, you as resource holders is now able to create a digital object called a ROA, which authorizes ASNs to originate your route, your prefix. And by doing so, you're now enabling any BGP speaker that is RPKI enabled to then verify this information and make necessary policies and rules that they need to apply. So for the longest time, we basically, over the years, we have seen significant growth in RPKI adoption. We have seen that we now have 60% of routes globally is covered by ROA. And about 30% of that is now, to some extent, implementing route origin validation. But as we all know, this is only half of the story. The other half is looking at the path that a route has taken to get to its destination. And that is what we call as AS path validation. With this, comes ASPA. So let's try to dive deeper into what exactly ASPA is. So ASPA stands for Autonomous System Provider Authorization, right? It is a digital object that is part of the RPKI framework. Through this, resource holders, again, is now able to authorize other ASNs and specify that they are their provider networks. As an example, you can see a customer AS45192, specifying through the ASPA record that it has 2 providers in the list. ASPA is defined in 2 IETF documents. That's the ASPA profile, which describes the ASPA object itself. And there's also the ASPA verification, which explains how the verification process or the algorithm works with ASPA. So why is it useful? For a couple of reasons that you can see here. Firstly, it helps detect and mitigate route leaks, one of the issues that we're trying to address with routing security. Secondly, it can protect against certain types of forged origin or forged path attack. Using the information, the adjacency information of ASPA, you can verify certain links, and it makes it difficult for attackers to then execute an attack. And they would have to resort to creating longer AS path to be able to be accepted. Now, most of you are familiar with ROA, so let's do a comparison between the two. ROA verifies the origin. And by that, we mean that ROA will now require both the AS number and its associated prefix. On the other hand, ASPA verifies the path. So really, you only require the AS ends in the AS path, not necessarily the prefixes itself. You can think of it as ROA answering the question, who is allowed to announce this prefix? Therefore, you require both the AS number and the prefix to answer that. With ASPA, you're answering the question, is this route taking a legitimate path through the network? Therefore, really, you only need the AS numbers on the list, or the AS path. Now, the ASPA process starts basically the first step in the ASPA process starts with attestation, wherein a customer AS creates an ASPA object. So by doing so, a resource holder like yourself is essentially declaring that these specific ASNs are my legitimate upstream providers. But why the customer AS? You know, the design for that is that you are allowing the customers instead of the providers to make this declaration. It's kind of like a bottom-up security model wherein your customer has the authority, they are the authoritative source, which makes sense, right? Because you would know better compared to the provider who are your transit, who are your upstream providers. The next step in the ASPA process is the verification. So in this step, a BGP router who is implementing RPKI will then be able to check the AS path of each route entry against the ASPA object itself. It uses the same RPKI infrastructure. You have a validator that fetches the information from the repositories and then pushes that information into your routers using the RTR protocol. So the core principle that we're trying to implement here is what we call as valley-free routing. So in a typical topology, it follows what we see as like an up-down structure, kind of like a mountain structure. It starts with customers announcing their routes up to a provider, goes up, kind of like we have an up ramp. At some point, it goes laterally and eventually comes down until it reaches the other customer. So you have your down ramp. So a typical mountain structure. So the rule here is simple. If you see a provider to customer and a customer to provider setup, then it creates a valley or a dip in the route. Therefore, this indicates a route leak. What about the verification process? ASPA follows the path validation function, which then looks at the AS to AS relationship from the origin. There are three possible outcomes here. One, it can be a provider. It means that there's an ASPA record that exists, and there is a hop confirmed that it is a customer to provider relationship. It can also be not provider if there is an ASPA record that exists. However, the next AS on the list is not the authorized provider. So it's a not provider. And then lastly, no attestation. So for that one, it just means that there's no ASPA record. So really, we cannot make any determination. So using these three outcomes, these are the building blocks for the upstream or the upward and downward validation or verification algorithm that then decides whether an RPKI ASPA state would be valid, invalid, or unknown. So that's kind of like how it works. Now, for us to understand the algorithm a little bit better, let's look at some examples. So we have two main processes essentially in ASPA. We have the upstream validation, and we also have the downstream validation. Upstream is when the resource, or the receiving AS is upstream of its neighbor. And then obviously it is downstream if it's downstream of its neighbor. Upstream validation is much more simple. Therefore, let's start with that. So on a high level, it follows these rules. Number one, If an AS path has a single entry, it will be valid. Number 2, if an AS path contains a hop from provider to customer. So here you're expecting up, customer up, right? But then you see a dip from provider down to customer, it will be invalid. Number 3, if an AS path contains a hop, however, there is no ASPA, so really, again, you don't know or you cannot determine, therefore it is unknown. Now, for all other cases, everything will be from customer to provider, therefore it will be valid. So we're following that general principle, and now looking at some examples. The simplest one is a single element AS path. Your receiving AS is receiving, a route originated from its neighbor, essentially from AS1 in this case. For this, the relationship is clear. AS, receiving AS is expecting a route announcement coming from AS1. Therefore, you don't really need the ASPA state. It is irrelevant in this case. This is valid because there is no possibility for there to be a route leak. However, let me go back to that one. However, in the case where your receiving AS decides to then propagate that further to its neighbors, AS1 will then have to create or issue an ASPA. So the relationship between AS1 and AS is clear for all the other routers to then do the validation process. Another example is a 2-element AS path, and in this case, AS1 has not created or has not issued an ASPA. We now know the relationship between our receiving AS and AS2. However, in this case, without an ASPA, there is no way for us to be able to determine the relationship or the association between AS1 and AS2. Therefore, in this example, it will be unknown. All right? Next example. This is the same example as the previous one. However, in this case, AS1 has now issued an ASPA listing AS2 as its provider. So we have an ASPA that exists. For this case, we can see that all of the relationship AS1 to AS2 is customer to provider, and we understand the association between AS and AS2. For this example, it will be valid. All the associations are from the customer going to its provider. Now, let's look at another example. If AS1 in this case has also issued an ASPA, however, it doesn't list AS2 as its provider. In the ASPA, it shows AS3 as its upstream. So for this case, as you can see, AS1 shouldn't be sending routes to AS2, so the possibility of a route leak is very high. Therefore, this is invalid. So far we've shown you examples of upstream validation, and as I said, is it much simpler? Now let's look at downstream validation. Similar to the upstream one, these are the rules that generally apply. Number 1, if an AS path has an up ramp, so how many customer to provider links you will have, but eventually goes to a down ramp. Again, these are typical mountain structure, right? And there are no hops in between or single lateral hops. This one is considered as valid. However, if there is a valley, a provider to customer to provider hop, then it will be invalid. For all other cases, we cannot determine, therefore it is going to be unknown. So those are the use cases. Now looking at an example, the first one is similar to the upstream example, the simplest, having only a single origin. This time around, it will be coming from the upstream provider. Again, similarly, the relationship between the receiving AS and AS1 is very clear. Therefore, the ASPA state is irrelevant in this case. This is considered as valid because there's no possibility for there to be a route leak. If we now have a 2-element AS path and no ASPA has been issued by AS1, In the upstream example, if you remember, this will show as unknown. However, in the downstream example, there is still no possibility for there to be a route leak in this scenario. Therefore, this is going to be valid. Now, when we increase the number of elements in our AS path, say for example, in this case, we now have a 3-element AS path with no ASPA issued by any of the routes in the path, we won't be able to verify. Therefore, it's going to be unknown. Notice that there is a very big chance that AS2 potentially is a customer in this case of both AS1 and AS3. So in that case, we will be seeing a valley. However, given that there is no ASPA, we cannot determine that. So this has to remain as unknown. Another thing to consider is that ASPA needs to be supporting incremental adoption. Therefore, again, we will be keeping this as unknown. Now, it's very easy for this to become valid though, if one of the elements in our 3-element AS path now issues an ASPA. In this example, AS1 issued an ASPA listing provider 2 correctly as its upstream. We now have one that is valid, right? This whole AS path becomes valid. Route leak is no longer possible. Same goes if you do that for AS3. Instead of AS1, we have AS3 now issuing an ASPA, again listing AS2 as the upstream provider. For this case, similar to the previous one, this will also be valid. Now, suffices to say, if both of them issue an ASPA, so we have AS1 and AS3 issuing ASPAs, listing provider 2 as their upstream, okay? This will have the same outcome. This will also be valid. Now, just to complete the picture, both AS1 and AS3 in this case has issued an ASPA. What about AS2? So AS2 can also do the same. However, notice that there is no upstream for AS2. So in this case, to indicate the absence of a provider, AS2 will create an ASPA listing AS0 as its provider. So in this case, we now have all 3 elements of our AS path issuing correct ASPA records. It also shows, what we covered earlier, the typical up ramp from AS1 to AS2 and down ramp from AS2 to AS3. All right, so far in the last few examples, we have seen both valid and unknown examples. But what about invalid? Here is an example, similar to the previous one. However, in this case, both AS1 and AS3 issued an ASPA that does not include AS2 as its provider. So as you can tell from this case, the relationship between AS1, 2, and 3 is now unclear. Therefore, high possibility that there will be route leak in this case, so it is invalid. Another one is if you have a 4-element AS path. In this case, all 4 of our ASNs have issued correct ASPA. But as you can notice, look at AS3. AS3 is a customer of both AS2 and AS4. So you see a dip or a valley from AS2 to 3. So there is a leak from AS3 going up to AS4. Therefore, this is invalid. So with that, you've seen a few examples on how upstream and downstream algorithm works. So at this point, if you are planning or implementing, and how can I then, start implementing ASPA? The good news is there is ASPA support, RPKI software that we have been using, like we already have some foundation with the RPKI infrastructure, Krill Designer, the validators, Routinator, RPKI client, and Fort Validator do have support for ASPA. You may need to enable the feature in the configuration, but all of them do have ASPA support. For BGP routing software, both BIRD and OpenBGPD has support for ASPA for the versions listed here. Cisco IOS XR as of last year, also do have, they're doing an early field test, and as of early this year, that has now moved into active testing. So there is that support, and the ecosystem is moving rapidly in this. But of course, there's still one missing piece, and that is implementation on the RIR level. So good news again, both RIPE NCC and ARIN. So if you have resources from those two other regions, you would be able to create ASPA records. But of course, majority of us here maintain records in the APNIC region. APNIC is due to implement this at the end of Q2. That's not very long now. So please do watch out when that happens. And overall, the goal is for all the RIRs to be able to implement ASPA, hopefully by the end of this year. So with that, these are just some resources on both RIPE NCC and ARIN. When we have APNIC's version at some point, we will also be publishing that, so watch out for that again. And that's all I have for you. Thank you very much.
Thank you very much, Shane. Any question? Okay, so thank you, Shane. Okay, so for our next topic, ASPA RPKI for part validation. Okay, please help me to welcome Mr. Anurag Bhatia from Hurricane Electric.
Thank you. Thanks for the opportunity to present here. My name is Anurag Bhatia. I work at Hurricane Electric. This is an interesting time to be presenting, as Shane has already done the most of the hard work. So it's we have quite similar topic here. I'll be focusing more on the operational side of deployment and our experience with deploying it. The other important thing which you'll find difference in our slides would be that Shane's slides were quite nice with the graphics. They were really well made. So you already heard the introduction. ASPA stands for Autonomous System Authorization. Why we are here? Because what RPKI origin validation did was essentially replacing the route objects, which was an older mechanism for filtering. We are coming now with ASPA deployments to essentially do the path validation. You are essentially bringing the cryptography with good integrated tooling. Tooling is the important part here because if you have run route filtering in past, you would recognize that it was extremely tough with route objects and AS sets. Most of them required custom tooling. There was no standard mechanism for generating and pushing and updating filters in the routers. All of that required some sort of custom mechanism where you would generate and push and regularly update filters. It's more secure than AS sets. For those who may not know, AS sets is the concept coming from Internet Routing Registry. The original idea for IRR was to essentially have public registers where you would just go and put something what you are about to do, and then you do it. It wasn't supposed to essentially authenticate you. But later, as the time proceeded, we came up with the idea that there should be more authentication in place, and more challenges came up with the open registries, and that in itself created security issues. Besides the fact that many of the routing registries were holding outdated data. So you would often find older route objects, as well as you'll find AS sets with ASNs which were not even active customers for various ASNs anymore. So how filtering is done presently? It's important to understand the current situation before going with ASPA. It varies from operator to operator. Some operator filter based on route objects, some based on custom logic. Overall, route object based filtering is much lower than you may think of. Some of the operators look at the route object and generate static filter and just put them in the config. They don't actively probe these route objects on regular basis. Some of them filter only peers, some of them filter only upstream. So again, quite a custom setup. Very few filter upstream, coming with million plus routes in the routing table now. There's no standard end-to-end tooling. You may find BGP Q3 often quoted. It's an excellent tool for generating filters, but it's just a tool to generate filters. You still need some sort of wrapping around it to push them and then regularly update them, and also take care of extreme corner cases where you are failing to generate or where some problem has come up in the system. So there's no end-to-end integrated tooling which works with all the vendors at this point of time. Here's a case of example of ASPA record, how ASPA works. So essentially you have customer AS number, which is your on AS number. So in this example, you see a customer as AS11358. They have created this record. They would state their providers. So this is a snapshot I've taken from Routinator's API call. They have listed providers as AS835, 6939, 3497, and so on. And then you have TA, which is the trust anchor, as Erin. So this is a ASPA record which exists at this point of time with Erin, where a network, which is 11358, stating that these are my providers. You have tooling available. You can start making use of announcement via these providers. And as Shane explained in detail, anyone getting announcement outside of these providers, if they are not a peer, they should be essentially dropping. They would be considered a leak. You do create ASPA records only for upstream and not a peer. I'll explain more of that as we discuss route propagation in the valley-free routing again. Here's an example again. You have a provider 11708, a customer 11708. They got a single provider. Again, coming from Erin, and then another ASN with bunch of other upstreams listed out here. So you can add as many providers as you want. There are certain limitations, and some of these were discussed extensively when ASPA was in early stages, like should there be separate providers for IPv4 versus IPv6, or should there be separate providers based on continents? Ultimately, it was decided that the deployment would be kept quite simple, where you would only have provider, no family-specific relation, and as well as no specific relation on continents. This creates some trouble for some of the large providers who may have a situation where they may be peering with another ASN in a given continent, while they may be purchasing or selling transit to that ASN in the other continent. So those sort of corner cases do exist, as to point out. How to create ASPA record? They can be created in the same way as ROA once your registry starts supporting it. Again, it is in parallel to RPKI ROA for origin validation, ASPA for path validation. Just like you would create a ROA record with your registry, you can create ASPA record with your registry once they support it, or you can have a model with a hosted model where you can essentially have a delegation, and then you can run something like Krill or any other supporting software in your infrastructure and maintain certificates yourself and sign them. ASPA validation logic, it is done across the AS path, and it follows three possible states. Provider, not provider, or unknown state. So provider, which essentially means that the path has been validated and the announcement is validated. It is correct announcement as per the match. Not provider, where it is not a provider and it's essentially a leak, or unknown state, which would be there for quite a while now for the route as people go ahead with the signing. So unknown state, same as the unknown state in case of RPKI ROA, that the provider, either the network has not created, the ASN has not created, or the entire path cannot be validated. Similar to RPKI ROA, for not provider, typically operators are expected not to, so typically it is expected for not provider routes to be dropped, but in case of there would be there is a state of unknown state, the routes will not be dropped, because still it will take a while, few years at least, for the deployment to go through. Logic for rejection can be applied in the policy, so it can be selective. Just like RPKI ROV, networks are expected to roll out validation based on specific criteria, like they can always state that start rejecting invalids, ASPA invalids coming from downstream, followed by peers, and then followed by upstream, and so on. It's essentially a knob in the policy as expected. Here's the validation logic. Let's say you got I'm using these large ASNs because somehow using AS1, 2, and 3 is not a very good idea. Those are actually ASNs. But then it becomes tricky to speak these ASNs out. If I speak each of them out with this long string, you may not follow. So I'm going to just call the last digit. So you got 12, 13, 14, 20, and 00. So let's say 12 in the red is providing service here to the 20 in blue, and it got its upstream 13 and 14, and it got a peer which is 00. In this case, what you expect is 12 can have a record stating that 13 and 14 are its providers. So you got a ASPA record stating customer 12, 13 and 14 as its upstream. And then similarly for 20, it would state the 12 as its only provider. That's the case. Now, for someone validating, let's say someone at 13 is running a ASPA based validation, they would state that we are getting a route with this paths 13, 12, 20. They can look at the route object again coming from the routinator's cache. They can state whether the route is valid or not. In this case, if it is coming from 64512, it would be considered as a valid route, and their policy can just accept it. Case of route leak, let's say 64512, the red ends up in leaking route of yellow here. In this case, if they have a route, if they have an ASPA object stating that their upstream is something, essentially not 64512, anyone who is validating at the upper layer can go ahead and reject it. It's much easier to detect it this way, and because ASPA is coming from the trusted RIR infrastructure, there is no scope of routing registries or any other thing essentially polluting the data. So it would be considered as a trusted way to validate whether it's an upstream or not, or whether it's a leak or not. Concept of value-free routing, don't need to go that much in detail since Shane explained it, but essentially idea here is you got 20 in the corner with the red, using 21 as the upstream, 20 is the downstream, then you got 22 here as another downstream, then you got upstream 23, another downstream. Now, even without going into ASP, anyone looking at this might be able to see the problem, which is from 21 to 22, it makes sense because 22 is the customer, but from 22 to 23, the route should not be going anyway because a customer is learning route from an upstream and announcing to the other upstream. It's a classical leak problem. I personally find a lot of these leaks happen because people have hard a prefix-based filter facing their upstream rather than using BGP communities. So they end up in a situation where they might had some customer like 20 in past directly, so 22 might be serving 20 at some stage. Now 20 has moved on to someone else, and they are still learning that route, which is fine because they are supposed to learn full table, but they end up in announcing the indirectly learned route, and that causes the leak. So this is the situation showing the leak problem. So on the top, you'll see from 24's point of view, it would learn the route from each of them, 23, 22, 21, 20, and so on. This is clearly a leak. If the ASPA record exists, it will drop it. You can clearly see it is forming a valley between 1, 22, and 23. So if everyone has created an object, they would be able to detect it and drop it on the AS64524, the last one on the rightmost side. Another example, here's a case of no valley in the routing. So let's say you got 20 with upstream as 21, 21 and 23 are just peers, and 24 is just the customer. Two upstreams who happen to be peer, they are just sharing the routes of each of their customer. Perfectly normal situation, happens on BGP normally. In this scenario, if 24 is validating, they would treat it as a valid route, assuming again all of them have created the record in it. So no valley, all good in this example. So how ASP is configured for path validation? Well, routers supporting ASPA are supposed to connect with the routinator or the RPKI software. You can pick any other than routinator, Krill, or a bunch of others. Then you can enable the ASPA validation, and then you apply the policy. The exact config for now is largely unknown because vendors have yet to support it. But once it is supported, you can expect it to be in very similar mechanism like that of RPKI ROV due to the nature of these deployments. The support is rather limited, but Routinator now supports it. So on the software side, it's easy. Most of them have it. If you are running Routinator, you can go and check on the top. This is just a call for getting all the values out of Routinator. So you can see they will give you metadata, ROAS, as well as ASPS. So they will list out all the ASPS, and one can make use of that via RTR. In this example, it's just a API call, not essentially using RTR. With that overview in place now, I'll cover the deployment of ASPA across Hurricane Electric's backbone. So we have deployed the ASPA validation a couple of months back across our backbone. As of now, we are rejecting all invalids coming from anywhere, any peer, any customer across the world. We were able to do it before the formal support from vendors because we have a reactive system in place from very long time. We have been running a custom setup for route filtering. This was in place for RPKI origin validation as well as for doing a bunch of other things. So we ended up in plugging the ASPA as one more logic in that comprehensive system and started generating filters based on that. Just a second. I'm missing a slide here. Maybe it's not. Never mind. I'll explain. I think it's just a previous version of the slide. So the way it works in our scenario is our reactive system follows certain logic. So the usual standard logic, you would reject default routes, you would reject routes shorter than /24 in IPv4, smaller than /48 in IPv6. Then we have a bunch of other rules like we look at the ASNs which are not allocated and are coming in the routing table, we would reject them. We look at things like prefixes which are RPKI invalid as well as prefixes which are unsigned and are invalid based on IRR route object. And which are not matching any of the handles of the registry providers. So in the similar system logic, we now look at the AS path and validate it based on the ASPA logic. And if it is invalid based on ASPA logic, we push a reject filter on that edge router. So that's how it works in our scenario. Besides our backbone, we run this popular tool, bgp.he.net. We have added a page on bgp.he.net for tracing. This is a slightly older version of my slide. I think maybe I sent an updated one. So as of now, this is at 2% level. Apologies for being 1%. There is a status visible across all RIRs. So you can see more ASPA records from RIPE as well as from ERIN because they formally support it. So anyone in those regions can right now go and create records. So I think last I checked, RIPE was at around 1200 or something, and ERIN was again little more than 137 in this case. And right now, most of these ASNs are either test or people running research or enthusiasts, or a bunch of exchanges as well as some of the transit-free tier ones, which are creating ASPA record with AS0, stating that they don't have any upstream and their ASN should not be visible in the table. But it is expected that more and more ASNs will add. It's a classic chicken egg problem right now. There is less incentives for ISPs to learn and go around it and create records when there is not that many network filtering based on ASPA, while at the same time not that many network will filter unless these records exist. So it will take a time, just like most of other chicken egg cases around RPKI origin validation or things like DNSSEC validation. So it is expected it will eventually pick up. Some of the limitations, I stated some of them in past. So When a large number of networks do it only, then it will add a lot of value. You ideally want a scenario where there are no gaps. That is, everyone has signed, everyone has declared. In case of gaps, it will create situation where you will be able to, you will lack a mechanism to validate, even though it's a case of invalid, it's a case of route leak, but you will lack the ability to do that. It does not differ between peer in one continent, transit in another. I already explained that. No specific granularity between IPv4 and IPv6, and both ASPA and validation have to happen to be effective. Remember, this is not this is not about just creating the record. Validation also has to happen, and this is one of the challenges with RPKI ROA as well. So when Shane said we got 60% ROA coverage, it's excellent, but one of the challenges has been not that many regional operators are dropping RPKI invalid. Same with cloud players. Most of large cloud players are yet to drop RPKI invalid. So we were in a situation where people were just giving up checks without signing them, and no one was validating them, to now a situation where people are signing the checks, but no one is actually looking at validating the signature. So in case of RPKI ROA, ROV is still missing. It's there at tier 1 layer, it's there across some of the large operators, but still largely missing from large regional operators as well as cloud operators. So expect that to happen, and same you would expect the validation to happen on the ASP as well. Without that, it's a pointless exercise to just sign and no one actually looking at that signature. That's about it. My email is here. If you have any questions, feel free to ask here, or if we don't have much time, you can always email or meet me outside. We can have a chat about it.
Thank you very much. Any question? If you have some question, you can ask. I think we have maybe one or two questions. Okay. If you don't have question, thank you very much, Kun Anurag. For the last topic of this session, we should organize in Thai, so I switch in Thai language. Okay. So สำหรับท็อปิกสุดท้ายหัวข้อสุดท้ายนะคะของเซสชันนี้นะคะเราได้รับเกียรติจากคุณนาวินธรรมรักษานะคะจากมหาวิทยาลัยเชียงใหม่ซึ่งให้เกียรติมาแชร์ประสบการณ์ในเรื่องของการทำ VXLAN in campus เชียงใหม่ University Backbone ค่ะขอเชิญบนเวทีค่ะขอบคุณค่ะ
สวัสดีครับ I can speak in Thai okay วันนี้ก็จะเป็นเรื่องของ VXLAN in Campus Backbone นะครับปกติแล้ว VXLAN ที่เราเจอจะเป็นใน Data Center ใช่ไหมครับที่เราเชื่อมเซิร์ฟเวอร์หากันนะครับแต่ตอนนี้ผมได้มาฟังAPNIC Forum เมื่อ 2-3 ปีก่อนแล้วมีเรื่องของ VXLAN ที่ implement ใน Campus นะฮะก็เลยเอาไป implement ใช้ในมหาลัยนะครับมาแนะนำตัวกันก่อนครับผมนวินธรรมรักษ์นะครับเป็น Network Engineer นะครับที่มหาวิทยาลัยเชียงใหม่นะครับทำงานที่ITSC นะครับก็คือศูนย์คอมของมช.นั่นเองนะครับเนื้อหาในวันนี้นะครับก็จะมาเล่าถึงเน็ตเวิร์กของมหาวิทยาลัยเชียงใหม่นะครับว่ามีหน้าตาเป็นยังไงนะครับแล้วก็มีการเปลี่ยนแปลงไปยังไงบ้างจนถึง VXLAN นะครับก็จะได้เห็นไอเดียว่าระหว่างทางที่เกิดขึ้นเนี่ยทางมช.เราเปลี่ยนเน็ตเวิร์กยังไงบ้างแล้วไปเหมือนเน็ตเวิร์กของท่านตอนช่วงไหนเผื่อได้เป็นไอเดียนะครับนี่มาดูที่เน็ตเวิร์กของมหาวิทยาลัยเชียงใหม่กันก่อนนะครับอันนี้เป็นภาพของมช.นะครับมหาวิทยาลัยเชียงใหม่เราตัวเลขที่เป็นนักศึกษากับบุคลากรนะฮะนักศึกษาอยู่ที่ประมาณ 30,000 ถึง 40,000 บุคลากรอยู่ที่ประมาณ 13,000 นะฮะก็ถือว่าใหญ่มากแล้วก็มีหน่วยงานเป็นคณะหน่วยงานต่างๆ24หน่วยงานนะแล้วมีโรงพยาบาลด้วยนะครับก็น่าจะเป็นเหมือน provider ย่อยๆนะที่ดูแลลูกค้าใช่ไหมฮะแล้วก็มีพื้นที่ก็จะมาเยอะมากฮะใหญ่มากแล้วก็ Access Point ที่เราดูแลก็คือ 12,000 ตัวนะครับตอนนี้ทีนี้หน่วยงานที่ดูแลชื่อว่า ITSC นะครับ Information Technology Service Center ตัวนี้ก็คือเป็นศูนย์กลางที่คอยกระจายเน็ตเวิร์กไปให้หน่วยงานต่างๆนะฮะเราทำตัวเป็นเหมือน ISP ให้กับคณะให้กับโรงพยาบาลให้กับหน่วยงานต่างๆนะครับทีนี้ ในงานของผมนะครับเป็นฝ่าย Infrastructure นะครับก็จะมี Job เบื้องต้นJob หลักๆเนี่ยครับก็คืองาน Network นะที่ผมดูแลแล้วก็มีงานที่เป็น Wireless นะฮะมี Server มี Security พวก Firewall IPS ต่างๆนะฮะแล้วก็มีศูนย์ Data Center นะครับเป็น Private Cloud ของมหาลัยนะครับแล้ว Data Center ผมตอนนี้ Certify ISO 27001แล้วนะฮะแล้วก็27701ก็ได้แล้วด้วยนะครับถ้าใครสนใจมาขอคำปรึกษาได้นะครับแล้วสุดท้ายก็จะเป็น HPC นะครับ High Performance Computing ตอนนี้ก็รันขึ้นมาแล้วนะครับอันนี้งานหลักๆแต่ HPC เรานอกจากงาน Network แล้วก็จะมีเรื่องของ Programming Application ก็คือเป็นส่วนงานย่อยๆนะครับทีนี้มาอยู่ที่ CMUnet ก่อน CMUnet คือชื่อของ Backbone มหาลัยของผมนะครับอันนี้คือหน้าตาปัจจุบันนะครับจะให้ดูตรงCore Network นะฮะจะมีเราเตอร์2ตัวนะฮะ Tier BGP อันนี้ก็คือส่วนที่ต่อกับ ASP นะครับแล้วก็จะแยกโซนมาเป็นโซนของเซิร์ฟเวอร์ที่อยู่ในด้านเตอร์นะฮะมี Core Switch คุมอยู่มี Firewall ตอนนี้ใช้4ตัวนะครับ Palo Alto ก็ต่อเข้ากับ Backbone แล้วก็มีโซนของที่ดูแล Wireless นะฮะก็จะข้างหลัง Wireless ก็จะเป็น Controller ต่างๆนะครับทีนี้ส่วนที่เป็น Campus ก็คือจาก Core Switch ตรงกลางนี้ลงมาที่ตัวนี้นะฮะ Distribute ก็คือเหมือนป๊อปที่กระจายใช่ไหมฮะตรงนี้ Distribute แล้วก็ข้างล่างสุดนี้เป็น Access Layer ที่จะเอาสวิตช์ไปวางให้กับหน่วยงานต่างๆที่ใช้บริการเรานะครับทีนี้เราก็ดีไซน์ด้วยทฤษฎีทั่วพื้นฐานเลยฮะ T-tier Architecture นะครับมี Core Distribute แล้วก็ Access นะครับทีนี้เมื่อก่อนเนี่ยประมาณสัก10 กว่าปีก่อนนะครับในยุคที่สวิตช์เลเยอร์3มันราคาแพงเนาะเรายังไม่ได้ใช้เราก็เอาสวิตช์เลเยอร์3เนี่ยไปวางตรงที่ Distribute นะครับแล้วก็เชื่อมลงมาหาคณะด้วย VLAN นะครับเป็นเอาสวิตช์เลเยอร์2ไปวางตามหน่วยงานต่างๆเป็น Access นะครับทีนี้เกตเวย์ของเราเลเยอร์3ก็จะอยู่ที่ Distributeเราก็ใช้5นี้มาเมื่อก่อนนะฮะใช้ Cisco 2960ทีนี้มันก็จะมีปัญหาตรงที่ว่าพอเราขยาย Wi-Fi เข้ามาเนี่ยให้ดูตรงนี้นิดนึงนะฮะตัวหน่วยงานเขาจะมีอุปกรณ์ของเขามาเชื่อมต่อกับเรานะครับตรงนี้ Access ก็คือส่วนของผม Access ที่ให้บริการที่ไปวางที่คณะหน่วยงานเขาก็จะมี Firewall ของเขามี Backbone ของเขามาเชื่อมต่อนะครับแล้วของผมก็จะมีเซอร์วิสที่เป็น Wi-Fi แยกออกมาทีเนี้ยพอมันไปวางคู่กันในคณะเนี่ยมันก็จะเกิดเหตุการณ์ที่ว่าเขาเอาสายมาปลั๊กเข้าหาสวิตช์ของผมแล้วมันก็เกิดลูปใช่ไหมเนี่ยตรงนี้จะเป็นลูปนะฮะพอลูปเกิดขึ้นปุ๊บเนี่ยสิ่งที่ตามมาก็คือ Distribute มันจะตายนะครับคือมันลูปมันก็ไปทั้ง Distribute เลยคราวนี้ปัญหาก็คือคณะอื่นๆที่ไม่เกี่ยวข้องก็จะพังไปด้วยนะเหตุการณ์นี้เกิดขึ้นค่อนข้างบ่อยนะครับทีนี้นอกจากนี้นะฮะนี่เป็นเซอร์วิสสมัยก่อนนะฮะก็คือเราเอา VLAN Layer 2นะครับย้อนกลับเข้าไปใน Distribute ของเราด้วยเพื่อ provide เป็น branch ให้กับหน่วยงานสมมติว่าหน่วยงานเขามี branch 2 ที่ใช่ไหมฮะผม access VLAN ไปเป็นเส้นหลักให้เขาก็อยากได้หลัง VLAN ไปโผล่ที่บ้านเขาไม่อยากทำ VPN นะฮะก็ปลั๊ก VLAN ย้อนกลับไปมาออกที่access อีกตัวหนึ่งนะครับอันนี้ก็เป็นปัญหานะครับทีนี้เราก็ต้องการที่จะเปลี่ยนแปลงเน็ตเวิร์กของเราให้มันง่ายขึ้นให้มันไม่ซับซ้อนนะครับเราก็เลยใช้ตอนประมาณปี 2020 เนาะเราได้สวิตช์เลเยอร์3มาค่อนข้างคือสวิตช์เลเยอร์3ราคามันค่อนข้างโอเคแล้วเราก็ implement ตัวเลเยอร์3เนี่ยแทนที่เลเยอร์2นะครับหมายความว่าข้างบนเนี่ยเราจะเป็น IP หมดเลยแล้วเราเอาแค่ให้หน่วยงานเนี่ยเอา VLAN มาเสียบหาเราหรือเอาไฟวอลเขามาต่อเข้าที่สวิตช์เลเยอร์3เรานะครับพอได้อย่างนี้ปุ๊บเราใช้ตัว Distribute เราใช้ Cisco Catalyst 9005 นะฮะแล้วก็ตัว Access เราใช้เป็น 9003 นะครับทีนี้พอ เรารีดีไซน์ตอนปี 2020 เนี่ยสิ่งที่เราได้คือทุกตัวของเราเนี่ยสวิตช์ที่เรากระจายไปจะเป็นเลเยอร์3หมดเลยนะครับถ้าพอได้เลเยอร์3ปุ๊บเนี่ยเรารัน OSPF ทั้งหมดภาพที่ได้ของเราก็คือ underlay network ตอนเราเรียนเวิร์กช็อป BGP ใช่ไหมฮะเราต้องขึ้น underlay network นะใครเข้าเวิร์กช็อปตอนนี้เราเป็น underlay แล้วอุปกรณ์ทุกตัวสามารถปิงหากันได้นะครับไม่มี VLAN จะไปโผล่ตรงหลัง core switch นะฮะเพื่อออกไปหาโซนที่เราดูแลนะครับแต่ว่าตัว core backbone เนี่ย core มา distribute แล้วก็ access เนี่ยจะเป็น IP หมดเลยเพราะฉะนั้นปัญหาเรื่อง loop จะไม่มีละใน backbone นะครับจากเมื่อก่อนนะฮะfirewall ของคณะจะ access เข้าตัว access layer ของเราใช่ไหมฮะพอเรารีดีไซน์ปุ๊บเนี่ยถ้ามันก็จะออกมาเป็น firewall เขาจะเพียร์ด้วย IP หากันเราทำ static แล้วไปหาลูกค้าชี้ default มาหาเราคุณไหมฮะ ISP ใช้ท่านี้ใช่ไหมฮะ corporate ลูกค้า corporate น่าจะออกเป็นท่านี้นะครับพอเราได้ท่านี้ปุ๊บก็เน็ตเวิร์กเราก็จะนิ่งขึ้นเพราะว่าเวลามันเกิดลูปที่ตรงเนี้ยครับเวลามันมีลูปเนี่ยหน่วยงานเขาจะตายเองเขาจะไม่มายุ่งอะไรกับ access เราละนะครับเพราะมันเป็น IP นะทีนี้พอเราได้ underlay มาใช้งานสัก 2-3 ปีเราก็อยากจะคิดว่ามีอะไรมาวิ่งบน underlay network ของเราบ้างนะฮะก็คือเราก็หา overlay มาทำนะครับสิ่งที่เรามีตอนนั้นก็คือเรามี firewall ตัวใหญ่อยู่ที่ซื้อมาตัวหนึ่ง performance มันค่อนข้างเหลือนะครับเราก็คิดว่าตอนนั้นน่ะหน่วยงานเล็กๆบางหน่วยงานเนี่ยเขาต้องการจะลดงบประมาณนะฮะก็เลยไม่อยากจะซื้อ firewall เองก็มาใช้ firewall ของเรานะครับแล้วก็เรื่องของ staff ที่ต้องดูแล firewall เยอะๆเนี่ยค่อนข้างหายากนะเราก็ให้เขามาใช้ firewall ของเราแล้วเราจัดการจากส่วนกลางได้นะฮะมาดูว่าเราทำยังไงนะครับสิ่งที่เราต้องการก็คือต้องการ layer 2นะฮะ panel over IP เนี่ยข้ามจากฝั่ง faculty นะฮะผ่าน distribute ขึ้นไปหา firewall ที่อยู่ข้างบนคอใช่ไหมครับนั้นสิ่งที่เนี่ยเราต้องการตรงนี้ฮะตัว tunnel นี้โจทย์ของเราคือ tunnel อะไรที่จะส่ง IP ตัวเนี้ยตัว static route กับ default route เนี่ยไปหา firewall ที่อยู่ข้างบนที่อยู่หลัง core switch นะครับช้อยของเราก็จะมี VXLAN นะฮะ GRE ก็ใช้ได้นะฮะ L2TP V3 อันนี้ก็ใช้ได้แต่เก่าแล้วนะฮะถ้าเป็น provider ก็จะใช้ MPLS ใช่ไหมฮะ provider จะมี MPLS ได้อยู่นะฮะสุดท้ายแล้วเรามาเลือกใช้ VXLAN นะครับภาพของเราที่ได้เนี่ยก็คือหน่วยงานปลั๊กเข้ามาผ่าน VXLAN นะครับแล้วก็มาใช้ firewall ของเราตรงกลางเพราะฉะนั้นจะกี่หน่วยงานเขาก็จะเชื่อมมาหา firewall ตัวเดียวนะฮะแล้วเราก็จัดการแบ่ง firewall เป็น virtual นะฮะเพื่อให้แต่ละหน่วยงานเนี่ยได้ policy ของตัวเองนะครับอันนี้คอนเซ็ปต์จะมาประมาณนี้นะครับทีนี้สิ่งที่ต้องเตรียมตัวว่าเราบอกว่าเราจะใช้ท่านี้แล้วนะจะเอา VXLAN มาที่เป็น layer 2เนี่ยครับวิ่งบน network ของเราสิ่งที่เราต้องเตรียมก็คือจะมี3ส่วนนะฮะก็คือ underlay ที่เราต้องไปแก้ไขเพิ่มนะครับแล้วก็ config overlay เข้าไปแล้วก็ในส่วนของ firewall นะครับเรื่องของ policy อันนี้ไม่ขอเล่าแล้วกันมันเยอะนะฮะแล้วสุดท้ายเราก็พอเราเตรียมเสร็จปุ๊บเราก็จะ migrate ตัว network นะครับในส่วนของ underlay นะครับเมื่อกี้เราขึ้น OSPF เรียบร้อยแล้วใช่ไหมฮะพอเราอยากได้ VXLAN เราก็ไปทำ MTU ให้เป็น Jumbo Frame นะฮะ 9,000 กว่าเนี่ยฮะเพราะ config ที่ interface ให้ MTU มันเป็น 9,000 นะครับในส่วนนี้เราไม่จำเป็นต้องไป config ทั้ง backbone ฮะเรา config แค่ตัว access ที่ของหน่วยงานที่เขาต้องการใช้งานแค่นั้นนะฮะหน่วยงานไหนอยากใช้ก็เราก็ค่อยมาแก้จาก access ไป distribute แล้วก็ไป core นะฮะก็จะแก้แค่ไม่กี่ IP นะไม่กี่ interface นะunderlay เสร็จปุ๊บก็มา config overlay นะฮะ overlay มี2ส่วนก็คือ IBGP นะครับระหว่าง core กับ access แล้วก็ทำ VXLAN ก็คือ eVPN L2 VPN นะฮะในส่วนของการ PIBP ก็เหมือนเวิร์กช็อปของเราใช่ไหมฮะมีตัวเราเตอร์ BGP ที่เป็นตัว route reflector นะครับตัว core นะฮะแล้วก็ตัว access ก็ PIBGP ไปหาตัว core นะครับแล้วทั้งคู่ก็จะรัน L2 VPN eVPN นะฮะเพื่อหากันตัวนี้เราก็จะได้ท่อเราก็ได้ตัว peering มาแล้วนะฮะจากนั้นเราก็ config L2 VPN eVPN เข้าไปที่ core และ access นะฮะตัว access เนี่ยก็ config ให้มี VLAN เป็นเบอร์ที่เราต้องใช้นะฮะแล้วก็ตัว core ก็เติมค่อยๆเติมตัว access เข้าไปเพิ่มไปให้มันเพลียกันนะครับทีนี้เวลาเรา migration นะครับจากเดิมที่ตัว firewall ของเขาเนี่ยเพลียกับตัว access ของเราตัวนี้นะตรงสีเขียวๆนี่ใช่ไหมฮะพอเราต้องการเพลียไปปุ๊บมันก็จะเป็นอย่างนี้นะฮะสิ่งที่เราได้เรามีท่อมี tunnel ตัวนี้อยู่นะฮะแล้วก็ให้เขาขึ้น interface VLAN ที่ core switch ของเขาแล้วก็มาเพลียกับ interface VLAN ที่อยู่บน firewall ของเรานะครับพอ2ตัวนี้ปิงหาเจอเนี่ยมันก็จะได้เพลียเหมือน core switch ไปหา firewall ปกติเลยหลังจากนั้นก็เป็นการส่งข้อมูลหากันนะฮะทางหน่วยงานเขาก็จะตัด firewall ออกไปได้เลยเขาเอา core switch ของเขาต่อตรงกับ access switch เราได้เลยนะครับก็อันนี้ก็จะเป็นเรื่องของการทำ VXLAN บนแคมปัสนะครับก็มีประมาณนี้ครับมีคำถามไหมฮะมีคำถาม any question
มีคำถามไหมคะโอเคค่ะ
โอเคครับ
ถ้าไม่มี
ขอบคุณมาก
ขอบ
ค
คุณ
รั
มาก
บ
ค่ะ